Okay. Um, yeah, and I want to talk about basically the Institute for Venture Science, which is actually organized to promote revolutionary science. So, um, so the agenda for today, the brief agenda. First of all, are we really in the twilight of the scientific age, which certain authors, including this one, have suggested that, you know, the really wonderful, productive science is that a thing of the past? Um, and is the chronic decline, if indeed there is a chronic decline, is it curable? Can we do something about it? And what's needed to bring the cure? How can we change things so that we can realize more scientific revolutions? And how our Institute for Venture Science can fix the problem. So that's basically the agenda that I want to talk about. Now, to start off, suppose suppose everybody around you knew that the earth was flat. I can see it. I'm sitting right now in my home. I'm looking out. I see Lake Washington, a beautiful view, and it looks flat. So it wouldn't be so difficult for me to come to the conclusion that since the vast uh, uh, lake out there is flat, that perhaps the whole world, the whole earth is flat. And suppose someone comes around with the idea that, well, no, it's actually that the Earth is round, and the person has some evidence, like a picture, something like this, showing that it's round. Well, you'd think that an idea like that would be well received, would be welcome. But if you look at recent history, um, you you might be less than optimistic. Um, you hear a lot these days about progress, enormous progress. The public relations departments of universities and institutes are very active, touting all of and the magazines and such, newspapers, all the exciting findings that are happening. But the question that you might ask is how many of those are actually revolutionary, or how many of them are simply incremental. Now, you might ask a question, and it's a question I ask often, a question that you might ask yourself, how many scientific revolutions have there been since 1970? Now, I mean conceptual revolutions. I don't mean technological revolutions, like Zoom, for example, or your iPhone or my laptop. I don't mean that at all, because those are well funded by entrepreneurs who think that there could be some profit from that. I'm talking about conceptual revolutions, an idea that changes everything. And I mean realized revolutions, not promised revolutions like Laboratory X discovered a possible cure for cancer. And that's not the revolution I'm talking about. I'm talking about something that's happened, that's conceptual, that changes all of science, and not a promised revolution, but one that's actually occurred. So if you want to think about what I'm talking about, one of them is the splitting of the atom. So that changed everything, as you know, not always for the better, but it it was a revolution. And so when did that happen? Well, my recollection is right. It's around the early 1940s. And in Japan, this is better known, unfortunately, than other places. So 1940s, that would make it roughly 80 odd years ago. Um, Definite revolution, the idea that the atom or the nucleus could be split. So another one that we think of is DNA, the structure of DNA, the genetic material. And that was 1954, I think, approximately. So that would be 70 years ago. a long, long time ago. And those were clearly major scientific revolutions, no doubt. So now, how many modern revolutions have there been? So I would challenge you to think about that question while I'm talking. Maybe see if you can think of some of those revolutions that have occurred. I mean, say in the last 50 years, comparable ones to the ones I've shown. Well, the shortcut. This has already been done. It was done by Science magazine. I think most of you are aware of that. It was the 120th anniversary edition in 2005. And the editors of Science put their heads together, and they made a list in the calendar form, a list of what they felt were the major scientific revolutions in the past, starting at the time of the Greeks and winding up at 2005. And so this is what one of the pages looked like. They were fold-out pages, comparable to what we might see in, for example, Playboy magazine, but the topics are a bit different. So you can see this is what year we're talking about. This is the late 1800s. And you see Röntgen, X-rays that were discovered, and there's Einstein, and various people listed, by year, pretty much. And it's an impressive list. And then there's another fold-out page that deals with the more modern revolutions, and that's shown here. And you can see, for example, cloning of sheep is one of them, and many others. So what we did, or what I did, is I made two lists. I took a number of I think 8 of them, revolutions from early on, and some of the more modern revolutions. So I took from, for example, 1865 to 1905, and I took randomly a list of revolutions. And here are the names of the people: Alfred Nobel, who we all know; Maxwell for his equations; Thomas Edison, a great American inventor who is credited with the first useful bulb, which replaced the candle, the first useful one. There were others earlier. Marie Curie, J.J. Thomson, discovering the electron; Max Planck, the Wright brothers, and Einstein. And if I were to ask you, and I've asked other people, including lay people, not just scientists, how many of these scientists do you know? And most of them knew practically everyone, and scientists knew every single one. And then I did the same. I picked 8 of the revolutionary scientists from 1965 to 2005, another 40 years. And here are the lists. Here is the list. And the question is, well, how many of these scientists do you know? So I asked various people, including at the lunchroom of our university, and I got blank stares. Some of the scientists were able to identify 1 or 2, and most of the people never heard of any of these people. So quite a distinction between this group, between 1865 and 1905, and the new group. So the question is, well, are these really revolutions, or are they really just incremental progress that's been made? So I think you're getting the message. So why challenge conventional thinking with revolutionary ideas? I mean, that's a question you might ask. Aren't we making great progress? We hear so much from newspapers, magazines, journals, and it seems like the progress that's being made today is huge, absolutely huge, compared to what was happening, say, 50 or 60 years ago. And there's certainly a lot that's happening. The question is whether it's really revolutionary. So why are we need revolutions? Well, we advance through revolution. So I mentioned the splitting of the atom. Another one is the discovery of antibiotics. I can't remember the year, but I think it was about 100 years ago. And that led to the creation of the pharmaceutical industry. And double helix DNA, it led to all kinds of advances that we see now in the area of genomics. So these are really important. But now revolutions are sparse. They don't happen too often. And so I ask you, I'll give you a minute or so. How many revolutions can you name that have taken place during the past, say, 50 years? And remember, I mentioned about revolutions earlier. I mean revolutions that have already taken place, not promised, not technological revolutions, and revolutions that have succeeded already in changing your world. How many can you name? So I'll just keep quiet for 30 seconds or so, allow you a little time to think, and ask you if you can think. And I'm not going to ask each one of you how many you can name, but I think if you're having some difficulty thinking of ones that satisfy the criteria, I think you're in the same ballpark as I am, because there really have not been a whole lot. Okay, so why so few revolutions? And I think if we go into it, the problem is this. The problem is any revolutionary idea, or almost every revolutionary idea, challenges the status quo, right? And there are lots of stakeholders in the status quo, in the prevailing paradigm, and they feel threatened. So, for example, the round Earth idea, the stakeholders in the previous idea, or the alternative idea that the Earth is flat, they feel threatened. They don't want the answer to be, oh, the Earth is round. They don't like it because their career is in jeopardy. They feel threatened by it, and they don't want to be threatened. And these people, the experts in the shape of the Earth, for example, they're the ones who are reviewing the grant proposal. So if you have a grant proposal, and you're challenging an established view, just like the one I'm mentioning, the challenge of the flat Earth, what's going to happen is if you submit a grant proposal to some organization, they're going to pick out the greatest experts in the shape of the Earth and doing due diligence to be in charge of reviewing your application. So you're applying to study the idea that the Earth is round, and the person who's going to be reviewing your application these are the most prominent people in the flat Earth idea. So there's no chance, or very little chance, that you're going to succeed in the application, because basically your round Earth idea gets reviewed by a flat Earth person. And that's human nature. We like to protect our turf. So you're not going to get anywhere. And scientists have come to realize that this is a problem. And any scientist who has half a brain is not going to apply for a grant that challenges the reviewer of the grant, because they're going to lose out. And if they lose out, then they don't have any money to support their laboratory. People in the laboratory will be out of jobs, and they themselves might be out of a job, because many people, especially in the medical area, are supported by grant funds, not by university funds. So this is a problem. And I think this is one of the reasons why there are so few revolutions, because any revolutionary idea is going to be suppressed, either suppressed by the scientist who decides to not apply for it, or by the reviewer who says, no way. So a revolutionary change is suppressed. So, you know, what science is like these days, it's like this is the tree of knowledge. And the modern science dwelling place is not on these major limbs or the trunk, but right out at the very periphery. See, and if it's at the periphery, what it means is that it's not really a threat to any of the main limbs. You become an expert in this little hanging branch right here, and that's not going to impact people who have been brought up and espousing a view that lodges in this one of these main branches. It doesn't matter so much. So you become an expert in this little branch that's hanging out here, and your expertise is appreciated. You apply for a grant, and it's easy to get a grant because you have a good reputation, and this is an area, no matter what you find, it's not going to impact anything down here that's really important. So you're not a threat to any of these people. And that's today, I think that's what science is really all about, working at the periphery, uh, accruing incremental gains, and not challenging any of the branches here that might or might not be rotten. So it's safe to be here, to dwell here at the periphery, and it's non-disruptive. We keep things exactly as they are. We're not thinking about changing the whole system. So now, when do things change? Well, things change when somebody finds out that there's something wrong with one of these major limbs. So an example might be what was it, 500 years ago, when the church knew that the Earth was the center of the solar system, right? And then it was Copernicus and followed by Galileo, who realized that actually, no, it's the sun that's the center of the solar system. So that was a very major pruned limb, and it caused a lot of consternation among scientists, including this guy Bruno, who got burned at the stake for espousing those revolutionary views. So scientists don't get away easily with espousing views like that. So the heliocentric solar system, that's one example, the sun-centered solar system. That's a good example of one of these major limbs getting pruned. Another one is hand washing before surgery. So this was a Hungarian guy named Ignaz Semmelweis, and he went, got a job in the most prestigious hospital in all of Europe about 150 years ago. This was before Pasteur. He got a job there, and he was appointed to the obstetrics ward, and it soon became obvious that there was a big problem in the obstetrics ward because the expectant mothers who came in for delivery, they would get triaged, and if they got triaged to the midwives, they did just fine. If they got triaged to the doctors, many of them left in coffins. And so Semmelweis, he saw this and he was really curious about what was going on. And remember, this was before Pasteur, and nobody knew about microbes and dangers of bacterial infections and such. But he was astute. He looked around and he said he had an idea about what might be going on. He checked on the agendas of the doctors. And the first thing they did when they woke up in the morning and they came into the hospital, they did autopsies on the women who had died, and there were plenty of them, the night before. And then they went immediately to doing internal exams on the women who were about to give birth. Hadn't realized that there might be some transfer of bacteria or whatever. But Semmelweis figured it out, and he went to his esteemed colleagues at the university, at the hospital, and he said, I think I found out if I wash my hands, there's almost no mortality. And you think that his colleagues will have accepted his brilliant idea to save the lives, but no, they were arrogant. They refused this challenge to their authority. And meanwhile, the same practice continued for years. Women died, and they were so offended by the impudence of this young doctor that they consigned him to an insane asylum where he soon died. So this is, you might say, another pruned limb. These are just two examples of pruned limbs. And so if you got a pruned limb, the idea is you grow something from the pruned limb, and it should grow up a new green limb. And in the case of Semmelweis, it would be the discovery of so-called germs that would do this. And in the case of the solar system, it was the idea that, if the sun, not the Earth, is the center of the solar system, though it may offend some people, and especially the church, it led to a very much simpler understanding of what's going on, a real revolution. So let me see. This is a genuine revolutionary advance. Now, the idea is looking at something from a different angle. You may discover something that you had never thought of before. So you can see, obviously, here's a rectangle. However, if you look at it from a different direction, you may find out that it's a cylinder. It's not a rectangle after all. And by looking at things a different way, you may discover something really interesting about nature. And this is a sort of a fresh perspective, gives you a different reality. Now, the paradox is this, or there's one paradox. Long ago, 100 years ago, contemporary, let's take the contemporary situation. Right now, there's a lot of money for science. Scientists complain there's not enough money. Of course, everybody complains there's never enough for anything. But we have a pretty substantial amount of money, at least in this country, and I'm sure in Japan too, and in Europe, but almost no revolutions for 50 years. And yet, 100 years ago, at the time of Einstein, the support from granting agencies, it's not zero, but almost zero, a very small amount. And we had numerous revolutions. You remember that chart from Science magazine. Everybody knew and understood these revolutions. So what's going on? What's the reason that why are today's scientists stupider than scientists maybe 100 years ago? Or maybe are the problems harder now than they were? Or maybe is everything already known, so there are no more revolutions that are possible? Well, I think the reason lies in the culture of science today, the very culture of science. But what I mean by that is that the power is given to the experts to decide what's good, what's not good, what flies, what doesn't fly, and also vested interests like pharmaceutical companies and other various chemical companies. So a new idea comes in, you see, the experts are the ones who are going to be reviewing these ideas. And as I mentioned to you earlier, the idea the Earth is round, you get reviewed by flat Earth experts. And so, the new idea, the fresh idea is treated with scorn and disdain. What are you proposing? This is, absolute nonsense. This is crazy making. There's no way that we're going to fund any of this absolute nonsense. And these are the people who are making the judgment, the experts who stand to lose the most, because if the new idea is right, they're wrong. And nobody likes to be wrong. So there are actually plenty of round earth ideas out there. And some of these ideas are, just waiting to be acknowledged, but mostly we don't know about them because the information tends to be suppressed. And many people will say, quote, and this has been said to me, if the idea is any good, it would have been discovered earlier, as though it's impossible to have a new scientific revolution. It would have been discovered by somebody famous 100 years ago. But actually, there are many ideas out there just waiting to be embraced. And one of them is energy. Of course, energy is something that is in dire need of energy. And it was Tesla who found this is an installation on Long Island in New York that doesn't exist anymore. But Tesla demonstrated that you could take atmospheric energy, harness it for general use. But of course, the people who didn't like that idea made sure that the government threw down this structure, so it doesn't exist anymore. On the other hand, the idea of harnessing the electrical field that exists in the atmosphere, which is known to exist, plenty of evidence for that, but we don't learn the evidence. Mostly you have to go dig it up. So there's a device. I really like this device that capitalizes on that electricity in the atmosphere. And so the device consists of a conducting ring like this. This is a patent, by the way, 1925, almost 100 years old. And this ring, this conducting ring, is raised up in the air by a series of balloons. So you got the ring, and the ring rises up. And then a wire is hanging down, and the wire is connected to one terminal of a motor, and the other terminal of the motor is connected to the earth. So you've got to basically, if there's a potential difference between this altitude and the earth, you ought to be able to run the motor. And Clausen demonstrated that he could run the motor based on atmospheric electricity. So a very simple idea. And it's patented and it works. And it's demonstrating that you can actually get energy. If someone wants to capitalize on it, you can get energy from what exists in the atmosphere. Now, this is a device from our laboratory. Let's see if I can stop it for a moment. Let me start over. So, stop. Okay, so this is a frame made of aluminum foil. It's one electrode, and there's a second electrode which you can barely see. It's a thin wire from this post to this post, this post to this post, and so on. And so you have two electrodes, one here, and you connect high voltage between this electrode and this electrode. And when you do it, this is what happens. It lifts up. And we've had some of these going all the way up to the ceiling. And I know in Japan, they have a large building where one of these is built, and it can lift all the way up to the ceiling of the building. So again, this is an idea to harness the energy that already exists, and we can make use of this. So sorry, yeah. So these are just a couple of examples. Okay, now in the area of health, I'm trying to give you a few examples of ideas that are hanging around there that are waiting to be exploited, but revolutionary ideas that are difficult because the establishment resists very strongly. So there's this book that I came across, I think it was about 15 years ago, The Doctor Who Cures Cancer. And this guy, and his name was Emanuel Rivici, and he came from Romania and moved to the U.S. And what he would do with the patients is that his objective was to change the pH of the patient to some ideal level. He did this mostly through diet, and there are other means. And he was incredibly successful doing it. And his success. This is a quote, and this is a quote from the guy who was the head of the most prestigious cancer institute. He just retired in the U.S. It's the Keter. Sorry, let me just check my notes. What was well, anyway, at Sloan Kettering Cancer Institute, and his name was John Heller, and he had just retired. And his quote in the back of the book, I don't know how Rivici, how he does it, but people walk into his office dead and walk out alive. So this is an example, of a doctor who had enormous success in curing patients with cancer. Nobody knows about it. Nobody hears about it. And basically, the guy has been suppressed. And so his fantastic achievement is now basically lost. There are other problems that remain unsolved. Well, getting energy, I mentioned, is one of them. Curing cancer, understanding brain function and dysfunction, combating global warming, wiping out pandemics, eliminating starvation, et cetera, et cetera. And I mean, these are just waiting. And there are lots of ideas out there, but these ideas can't see the light of day because of the suppression by people who take up or espouse the conventional view to protect their own egos. One of them I just should mention briefly is the role of water in biology. And this is an area that I've been active in, and I don't have time to discuss it at all, but I just want to mention that this book is called The Fourth Phase of Water. We discovered a fourth phase, and we discovered that this phase is central to all of health. I don't have time to talk about it, but it's really popular. It's turned out, I'm flattered, turns out to be really popular. Okay, so I gave you a bunch of examples of many in need of support. Somehow these ideas need to see the light of day, and they mostly haven't been able to. So, whoops. Sorry, my computer seems to be behaving in a way that is not. Oh, yeah. Okay, so basically we invented or devised something called the Institute for Venture Science. And this is not an existing building. We would hope one day that we'll see this building coming up, but we're not yet there. And as I said, the idea is to promote revolutionary science because revolutionary science is critical to our future. So how does the Institute for Venture Science foster revolutionary advance? Well, we receive groundbreaking proposals, and we ask for a scathing critique from the field's leaders, and the applicant has a chance to respond to these scathing reviews. Because we know they're going to be scathing reviews because it'll be the flat earth people who are criticizing the round earth ideas. And if the applicant does a really good job in defending his or her position, that's a good sign. It's a sign that they're onto something. And we use evaluators from outside the field. So it's not a flat earth person reviewing a round earth idea. That doesn't happen. The people are, at least supposedly, the reviewers are supposedly neutral. And then the idea is to fund the best proposals liberally for 5 years or more, so that there's ample time to conduct research. And the most important thing is funding multiple groups pursuing the same theme. So, for example, let's take the round Earth idea. One person has the idea that the Earth is round, and let's say they're successful and they get a little money and they find additional evidence that the Earth is round. What happens? Well, you can imagine what happens. The flat Earth people are not happy one bit, and so they call this person a crackpot. Now, if you're the only person doing some oddball, seemingly oddball or revolutionary research, um, it's easy to be called a crackpot, and it doesn't work if you say, no, I'm not a crackpot. You lose. And it's easy to lose because the opposite side has the numbers. And it's not just one person who calls you a crackpot, but a whole bunch of others chime in right away. And so even though you have a good idea with data to support your idea, you lose. Now, we're funding multiple groups, say a dozen groups, studying the concept that the Earth might be round, you see. And suppose a dozen groups come up with evidence, each one using a different technique, with evidence that, indeed, the Earth is round. It's not flat. It's difficult for the other side to say all 12, all dozen of them are crackpots. That doesn't make any sense. And you can imagine the young people listening to their presentations of a dozen different groups who say, no, it's not flat, it's round. They'll pick up on the theme very quickly, and fly with it. And that's the idea. And within 2 or 3 years, I would predict we have a scientific revolution, or many scientific revolutions, depending on how many we can fund. So the round Earth idea, if it's just one person, one scientist, it doesn't fly. But if you've got a dozen scientists studying the same general issue, and they all come up with positive evidence, a scientific revolution is just about on its way. Our funding goal, maybe this is pie in the sky, maybe a $10 billion endowment we're thinking of. And the interest on that, if we're optimistic, $500 million a year. And that should be able to fund 50 independent ideas with, say, 10 labs following each idea simultaneously. It should be enough to do that. And if you think about $500 million per year interest on which this would operate, it's only less than 1% of the US annual research budget, a minuscule amount that can accomplish a huge amount, multiple revolutions. So, what's the impact of the revolutions? Well, revolutions give fresh insights, new solutions to problems that, we hadn't thought of before, and a bright future. At the same time, equally important, the revolutions create new technologies, right? I gave you the example of the identifying semiconduction, and now we have iPhones. Who would have expected that a few scientists at Bell Lab would come up with something that could lead to the technologies that are common today, to new technologies, economic revitalization, and a brighter future. So for people to invest in this, I can see a kind of amplification from the investment that would occur. So, and again, a good example is exactly the semiconductor materials that I talked about. So what happened 100 years ago? Well, whoops. So it led to diodes and transistors, right? Which led to photodiodes, which led to digital cameras and solar cells. And along a different line, it led to integrated circuits, microprocessors, computers, smartphones, etc. So a small investment into science has led and could lead to something equivalent to all that you see here. So there's a lot of attraction that could be induced to induce donors to donate to this organization or the equivalent organization. And the idea is, well, if Mr. Saito decides to donate a few $1 billion, might be the Saito Institute for Venture Science, et cetera, et cetera. And why can we make it happen? I'm just at the very end. We have an advisory panel with world-class experience. You probably don't recognize these names, but these are very, very substantial, very substantial people who are underwriting this or advocating this. And right now we have 5 selected proposals that have the capacity to change the world, and we're looking for funding. We have some, but not enough to make a difference. The website is IV as in intravenous, or Institute for Venture, ivscience.org, not .com, .org. If you would like to have questions or would like to donate a few $1 billion or something less, unthinkable ideas today, received wisdom tomorrow. Thank you very much. And I'm happy to answer questions. I'm sorry I went on too long.